This intricate golden structure is one of the coldest objects in the known universe. To operate, it sits at 15 millikelvin, a temperature lower than the vacuum of outer space. This hardware represents a total departure from the silicon-based evolution of the last century. It functions by manipulating the underlying physics of information itself. Classical supercomputers, like IBM's Watson, process data through massive rooms filled with server racks. A quantum machine, by contrast, focuses its power within a single hyper-cooled cylinder. The global race to build these machines exists because quantum computing operates on a mathematical plane that classical logic cannot access. All classical information is processed through bits, tiny silicon switches that exist in a state of 0 or 1. For decades, we mapped a vast landscape of mathematical problems by making binary switches smaller and faster. However, this grid has a physical boundary. Beyond it lies a dark ocean of exponential complexity, mapping atomic bonds or factoring massive numbers that binary logic cannot navigate. Finding a solution to these problems with a standard supercomputer would take billions of years of brute force calculation. Accessing this territory requires a completely different kind of mathematical vehicle. That vehicle is the qubit. A qubit operates as a fluid probability wave. Rather than being locked in a fixed state, it has a specific likelihood of being 0 or 1 at any given moment. These probabilistic states allow multiple qubits to interact and shift simultaneously, a behavior physically impossible for a rigid silicon bit. It is a mistake to view this as a computer simply checking every possible password at the same time. This architecture works by manipulating these overlapping probabilities, guiding a complex dataset toward a specific result. Quantum algorithms use these interactions to isolate an answer from the noise. Imagine tapping two spots in a still pond. Where the ripples collide, they add together to create a higher peak, which is constructive interference, or they cancel each other out entirely, which is destructive interference. The computer observes these wave collisions to identify the single most mathematically likely outcome. This process is highly inefficient for simple tasks like addition. Your calculator or your phone will always be the superior tool for standard arithmetic. Wave mechanics are designed for finding hidden structures and patterns within massive chaotic datasets. Shor's algorithm is a specific set of instructions designed to find the prime factors of incredibly large numbers. This is the basis for RSA encryption, the standard securing every modern internet transaction. RSA works because factoring these numbers is computationally impossible for binary systems. While today's machines only utilize a few hundred qubits, a processor with 1,000,000 qubits could resolve these calculations in hours rather than eons. The global race for quantum supremacy is an attempt to master these prime factors before financial and government institutions can establish new quantum-safe defenses. The same wave mechanics used to factor prime numbers allow us to map complex atomic structures and materials. Nature is not a binary system. At the molecular level, the universe operates strictly according to the laws of quantum physics. A machine that speaks the native language of these interactions allows us to engineer groundbreaking battery technologies, new medicines, and synthetic molecules with precision. This hardware serves as a submarine, enabling us to plunge into the previously inaccessible physics of the physical world. We are finally building a machine capable of speaking the native language of the physical universe.